Hello everyone, this is Wagada Ronald taking you through today's tutorial on Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum is proportional to the applied force that takes place in the direction of the force. So this F denotes the applied force, and momentum is the product of mass and velocity. So change in momentum means this is the final momentum, initial momentum, so the difference gives the change in momentum. And the T denotes the time taken for the change. So what is momentum? This is the product of mass of a body and its velocity. So momentum is given by mass times velocity. Impulse, this is the product of force on a body and the time for which it acts. The SI unit is Newton second or kilogram meter per second. So impulse is given by two formulas: one, force times time, or change in momentum. And we shall use that to go through this problem. A body of mass 0.5 kilograms is allowed to drop from rest from a point at distance of 5 meters above a horizontal concrete. When the ball first hits the floor, it rebounds to a height of 3.0 meters. Roman 1. What is the speed of the ball just after collision with the floor? And Roman 2. If the collision lasts for 0.01 seconds, find the average force which the flow exerts on the ball. So the first step is to make a sketch. It was dropped from a point 5 meters above the floor. This is the floor or concrete floor. This is the height, which is 5 meters. This is the ball. Initially it will be released. Because it is released, initial velocity will be 0. When it hits the ground, it will have a certain velocity, v1, which we don't know. That's why there's a question mark. So after a time of 0.101 seconds, this ball will rebound to a height of 3 meters, and at that point the final velocity will be 0. Now the first question, they want us to get the speed of the ball just after collision with the floor. They want u2. So we shall first consider motion CD. For motion CD, when we use the third equation of motion, remember we have v final velocity, which is 0. Initial velocity is what we want. We know the displacement, which is 3. So using the first equation of motion, v squared is 0, u squared is what we want, 2g. Now in L-level physics, g is taken as 9.81. You should note that, because elsewhere it has a different value. Others use 9.8 and others use 10. But in L-level physics, we shall use 9.81. Then the displacement is 3. When we make u2 the subject, we shall come up with 7.6720 meters per second upwards. I think you can see it's going upwards because it is rebounding. So that is the velocity they wanted in Roman 1. Roman 2, they say that if the collision lasts for 0.01 seconds, find the average force which the flow exerts on the ball. So the time is known, it is 0.01. So we shall first consider motion AB. Motion AB, we have initial velocity, we have the displacement, but we don't have the final velocity. So we shall first get the final velocity from third equation of motion. So v squared, v is what we want, u is 0, g is 9.81, and s is 5. When we make v1 the subject, we shall get 9.9045 meters per second downwards. Now note that this is upward, this is downwards. So when there's a change in direction, we denote it by a change in sign. So we shall let the upward velocities be positive and the downward velocities to be negative. So after that, we shall use the formula for impulse, which is force times time, and it's also given by a change in momentum. So this is the force which they want. Time was given as 0.01, and mass is 0.15 kilograms. Final velocity is 7. Final velocity, now we are dealing with this period when it is rebounding. This will act as our final velocity and this will act as our initial velocity for the time. So the final velocity is this u2, which was got as 7.6720. It is upwards, so it will be given a positive value, and the initial velocity is this one, which is 9.9045, and it is downwards, so it will be given a negative sign. So when you substitute, you come up with F as 878.825 newtons. So that is the average force they wanted. Problem 2. A ball of mass 500 grams traveling at a speed of 10 meters per second at 30 degrees to the horizontal strikes a vertical wall and rebounds with the same speed at 90 degrees from the original direction. If the ball is in contact with the wall for 0.008 seconds, calculate the average force exerted by the wall. So in this case, the ball is here, it moves in the direction of 30 degrees to the horizontal, that's when it hits the wall, and after hitting it rebounds so that it's at an angle of 90 degrees from the original path. So this was the original path, initial path. This will be 90, so it will leave the wall in that direction. Since this is 30, this will also be 30 degrees, and because this is 90 minus 30 will give us 60, which is that. So let the velocities to the right be positive. They will change in direction. So velocities to the right will be positive and those to the left will be negative. Therefore, we shall now consider the horizontal components. So horizontal component for velocity just before impact is this, which is 10 cos 30. And it's given by 5√2 meters per second. The horizontal component of velocity just after impact is this one. So it will be going to the left, meaning it will have a negative sign. So it will be 10 cos 60, which is that 10 cos 60, and gives us negative 5 meters per second. So applying the formula for impulse, F times t is equal to change in momentum. With this, the F which they want, time was given as 0.008. Mass has to be converted to kilograms, for 700 grams. So divide by 1000 to get kilograms. Final velocity is negative 5. And initial velocity is positive 5√2. When you use a calculator, we shall come up with 754.4417 newtons. And that's the average force which they wanted. That brings us to the end of our lesson. Thank you for watching, and please subscribe to my channel, ROA, a learning platform. I remain Walgada Ronald. Thank you.